Welcome back everyone to another video of chemical demonstrations, where today's topic is acid and base demonstrations. Now these demonstrations actually happened a few weeks ago, and since then my school got shut down for a few weeks due to COVID-19 and that type of thing. So I still have some videos planned for these few weeks, but they may not be quite as frequent because I won't be showing them to the class. Anyways, on to the topic of the video. Most acid and base demonstrations that you see online will just involve like some sort of indicator, and while I do demonstrate an indicator in this video, I wanted a couple of things that were more exciting than just watching something change color. The first demonstration that I did was with sulfuric acid, the reaction between sulfuric acid and sugar. Now this is a reaction that you may have seen before. It is in a lot of YouTube videos. Basically it just involves adding some sulfuric acid to some sugar, and when I did this reaction it took quite a while to get them to start reacting, and what I learned from doing this is that it can help to add some water to the sulfuric acid in order for the reaction to take place at a quicker rate. That's why part of this video is sped up, because it took a while to get started.
I would do half of that to start with, and then if it's going well, let it. Okay. But if it's not going well, you can have it extra. I'll give it a second.
Okay, hold up. It'll.
Pretty quickly, you're gonna maybe want to back away.
Yeah. I think it's starting. I think. Hold up. Should start any second now.
If it's supposed to have a low pH. Oh, there it goes.
Here we go. Here we go. Alright, back away.
Is there a zoom? Oh, is it Pharaoh's snake? Pharaoh's serpent reaction?
It might be known as that. I'm not sure what else it's.
How do I zoom?
Don't worry about that. I can do that in editing. But yeah, that's what it does. I've seen it on larger scales. Yeah, it's very hot. Like I can.
It's solid. It's not like all the toothpaste.
Yeah, it's pretty crumbly. I can like break pieces off.
Don't bring in urine.
It's pure
hydrochloric acid.
It's pure carbon, and yeah.
It won't focus.
That's all right. I can. It's pretty much just pure carbon, but might have some sulfuric acid. Yeah.
Pretty nice. That's something that YouTube. That's something that YouTube doesn't give you. That's something that YouTube's gonna block. No, you can't.
Here you go, Axel.
Oh yeah, that's. Now the reaction there is just basically the sulfuric acid protonating the sugar like crazy and giving all sorts of hydrogen ions to the sugar, and the sugar is turning into pure carbon and various gases that are produced in that reaction, and those gases are what causes it to expand into a column of pure carbon. And that's cool, but a better demonstration of acids and bases is a reaction with an indicator. Now, indicators are solutions that will react differently and color change in the presence of hydrogen ions versus hydroxide ions at different concentrations, and the one that I used was cabbage juice. There are videos on how to make cabbage juice an indicator for acids and bases, and I'll link to some of those in the doobly-doo, but don't worry about this just being a video about an indicator, because I have something exciting that I do with it at the end. But anyways, cabbage juice is an indicator that turns from purple to red in the presence of acids, and it will go deeper and deeper red depending on how strong the acid is. In the presence of bases, it will go blue, then green, and sometimes yellow, depending on the strength of the base. This is something that I demonstrate here. Around so that people can see a bit better. But I have a pH indicator, which is cabbage juice. It's been what's been causing the smells that you, yeah. So we're gonna. This indicator is a very versatile indicator. So it can be used for strong acids, weak acids, strong bases, and weak bases. And so I'm going to demonstrate that really quickly. I have some baking soda, which is a weak base here, and I'm going to put that into this cabbage juice, which is currently purple, but it is going to change with enough, once I get enough.
You gotta take a picture. Come on, Dad.
See, look, now it's turning blue.
Seriously, what color is it?
No, I'm gonna have to go with your.
It's turning blue. Okay. Now, this is a weak acid.
Should I go?
Yeah.
How much is a bit?
Just do the whole thing, and then it's gonna take a few more, and then. And I'll stir it. Okay. And you can see it's becoming a bit lighter color.
Can you drink that? Raspberry flavored cabbage. Is it safe to drink?
Probably. But
Don't drink it.
These next two you don't. These next two are ones that you don't want to drink. And I have gloves, so I'm going to do these ones. No, not drink it. This is sodium hydroxide. It's a strong base, and so I'll put it in. I'll put it a couple of these, and it turns green, and I might be able to get it to go yellow. Not sure. Maybe it might go yellow, but not. But it might just stay green. I'm not sure. Yeah, it's staying green. Anyways. All right.
What's HCl?
Hydrochloric acid.
Yes, I put them in a strained tomato bottle. So, it's.
You drink that?
Strained tomatoes.
Okay, I put the cabbage juice in a strained tomato bottle.
Strained tomatoes.
Tomatoes that have been strained. Anyways,
Made in Italy.
anyways, so that demonstrates acids and bases, but I wanted something a bit more exciting. So I thought, what if you could make color-changing foam with this indicator? And I thought of the idea of mixing baking soda and vinegar along with some soap to create some foam, except doing that in the cabbage juice, and you would have some foam that would have stripes based on the pH of a particular region of the foam, and it might also color change as well as reactions took place. Of course, baking soda and vinegar are a weak acid and a weak base, and they will neutralize each other and also release CO2 in the process, which is a gas, expands, and creates foam. Now, I wanted to mix the baking soda into a soap solution because soap is also a weak base, just like baking soda, and have the vinegar, the weak acid, in the cabbage juice ready for baking soda to be put in. Also, for some reason, the indicator worked a lot better when I mixed it together in the large graduated cylinder for whatever reason. Anyways, this is the really exciting one, so if you're not here, you will want to... You'll notice that I have this over the sink, and that's because I'm going to put a bunch of vinegar in this one, and then I have a baking soda and soap solution in there. Alright, I'm gonna put okay, hold on, let me get some more vinegar for this. And then alright. And now here comes the exciting part that you're alright, here, will you hold this? Okay, so I have here a solution of baking soda and soap, and because there's soap in it. Okay. Alright, you're ready to dump that in there?
All of it?
Yeah, and we're gonna get some color changing foam here. The foam is gonna color change. Get ready to...
I'm nervous. Wait, at the same time?
Yes.
Okay.
Ready? 1, 2, 3.
My heart is pounding. Oh, you... There's no warning!
And you can see the foam started out red, but now it's changing to a more purple color. And
It does.
No, it doesn't. I have it on you.
So, in this part, I tried to add some sodium hydroxide to it to see if I could get some stripes of green in the foam as well, but it didn't work out so well, as you will see here.
I got it mid-reaction. Look at this face.
Alright, so there's gonna be... to eventually get that out of there. Anyways. There's some good pictures here.
Alright. Anybody caught in the splash zone?
Alright, and you can see the
It's just
foam.
vinegar and baking soda and cabbage.
You can see the foam is changing color over here, and there's some purple and some blue, and that is the neutralization process that is currently going on. And let's just put some more sodium hydroxide into it, why don't we?
Is it going to change
It will, but it's oh yeah, you can see over here at the bottom, it's changing. You can see many more stripes. You wanna, yeah. Here,
Well,
can you
I'm
come over
afraid.
to this angle?
Well, if I go in, it gets blurry.
Yeah, I told you not to. And you can see there's a lot of stripes here.
Sorry about that. I'll just bring it in like this. Oh, yeah, this is better.
Yeah. And
It's just cabbage.
yeah. So in pictures like these, you can really see the stripes in the foam and how different sections of the foam are different pHs. My camera wasn't picking it up quite as well as these pictures. So you can see there that it created some pretty cool stripes in the foam, and it's something that you don't normally get in reactions that produce foam, is stripes that naturally occur that aren't put there by some external process. And I just thought it was something that was kind of interesting that had never really been seen on YouTube before. But you can really tell that the foam is changing colors and has multiple stages to its color when you watch it in slow motion like this. You can see that the first wave is a reddish pink, and the second wave is more purple, and beyond that it gets more and more purple, and eventually some of it in the graduated cylinder is blue. So hopefully you've enjoyed this chemical demonstration video. I hope you'll please consider subscribing, and I hope you're all staying safe from the coronavirus. It really is a dangerous thing. I'll try to continue making videos with my school being closed, but I'm not sure at what frequency I'll be able to continue that. I will definitely continue to make more videos for my channel in the future, but I don't know how long it'll be until the next one gets uploaded. Thank you for watching, and I hope you will continue to see my chemical demonstration videos.